Hi Jennifer, thanks for your email. I've got your question here on the screen, and I'm just going to go back to your email here, make sure I'm answering it. All right, so in order to find the critical number, you've actually found your derivative correctly. Critical numbers are what you get when you set it equal to 0, and so if you're solving this, your critical number actually isn't 3. 3 is an asymptote because that'll make this function undefined at that value, because it gives you a 0 in the denominator of this function, of this part of the function. But finding the critical number is solving for x when you set the first derivative equal to 0. And so that would give us, I'm going to do a little switcheroo here and put the left-hand side of the equation, I'm going to write it like that. So if you were doing that, you would, I guess the easiest way would be to multiply everything by x minus 3 to make a common denominator. And then you would end up with x minus 7 equals 0 and x equals 7. And so if I put a value of x equals 7 into the denominator of that function, into this function, I would get 1 minus 4 over 7 minus 3, which would be 1 minus 4 over 4, which is 1 over 1, which is, 1 minus 1, which is 0. So the critical value is x equals 7, and then you would find the y value by putting that back into the original function. You're going to sub in x equals 7 into the original function to get the y value, and that'll give you your point x, y for the critical point. So what you need to do next is, usually a critical point is a turning point where you're turning from a maximum to or to a minimum. And so with a maximum, it means that the function is increasing as you're getting there. So maximum looks like this, and then you get to the top, and then it starts to decrease. A minimum is like this, where you're going down to a certain point and you kind of hit rock bottom and then you're going back up. So that's what you need to determine when you're saying that you need to find the open intervals where the function is increasing or decreasing. So we're actually talking about slopes there. So if you look at the first example with a maximum, your slopes are increasing. They're all positive as you're going up towards your point, the critical point. And then they're decreasing. They're negative. Oh, I missed. Sorry. They're negative slopes. Oh dear. Those are supposed to be tangent to the curve. They're supposed to be touching the curve. But they're all negative slope tangents coming down. So that's increasing. And this is decreasing. Sorry, that's so messy. And the opposite would be true for a minimum point. First you're decreasing because you're coming down to it, and then your slopes are going to increase again. You're going to go up and have positive slopes, okay? So what you need to do is find a way to test, and there's a couple of ways to do that. Not sure exactly where you are in your course in terms of all of that. So one way to do it is to take your derivative function, your f prime, and you're going to do a sort of a chart. You're going to put 7 here because we know that f prime is at 7 is equal to 0 exactly at the turning point. And you're going to try a number just before 7, so 6 would do, and then a number just after 7, so 8 would do. And you're just going to take those values and put them into the function and see whether they're positive or negative. And so in this case, if we put 6 in, we're going to get a positive value for the derivative. If we put 8 in, we're going to get a positive value. Did I say that backwards? Sorry, there's a lot going on in our house right now. I'm having a hard time concentrating. If I put 6 in, I'm going to have 1 minus 4 over 6 minus 3, which is 1 minus 4 over 3, so it's 1 minus 4 thirds, which is negative 1 third. That's how I got the negative here. Okay, and if you put 8 in, you'll get a positive value. So that tells us where the function is increasing and decreasing. For this function, it would be for all x less than 7 that we are decreasing, and for increasing, it would be for all x greater than 7, and for x at 7, we are at that 0 critical point where it's turning. So that's how you answer a question like that. The second way that you would have of determining whether it's increasing or decreasing would be to test in the second derivative. And I'm not sure how far you've gotten in your course, if you're at the second derivative test yet or not, so I'm not sure exactly what to tell you. The second derivative would just be to take the derivative of the first derivative, and if you substitute the value of 7 in there, that will tell you immediately whether it's a max or a min. If you put the value in and you get a negative, then it's a max. If you put x equals 7 into the second derivative and you get a positive, then it's a min. And I did say that the right way around. I know it sounds backwards, but it's right. So that's the second way to test something like that, and both will work. I'm just not sure exactly where you're at in your course. Okay? So if you want some more clarification, give me another email and I will send you some more information on that.